Hi everybody, in this video, let's look at how do we use integration to find the volume of revolution. If this part of the curve is rotated 360 degrees about the x-axis, it actually form a solid. The volume of this solid form is called volume of revolution. So to find the volume of revolution when a curve is rotated 360 degrees about the x-axis, we integrate pi y squared with respect to x. So remember, about the x-axis, pi y squared dx. If this is dx, these two numbers, lower limit and upper limit, will come from the x-axis. So if a curve is rotated 360 degrees, let's say this part of the curve is rotated 360 degrees about the y-axis. So to find the volume of revolution, we need to use this formula. Integrate pi x squared dy about the y-axis dy. This is dy. These two numbers, lower limit and upper limit, will come from y-axis. Okay, so just remember, to find the volume of revolution when a curve is rotated 360 degrees about the x-axis, pi y squared dx. To find the volume of revolution when a curve is rotated 360 degrees about the y-axis, pi x squared dy. Okay, before I show some example, let's look at this one first. Now I have a straight line over here. If I rotate this straight line 360 degrees about the x-axis, it's actually form a cone. So in this situation, if we want to find the volume of revolution, we can use integration method, or we can just use the formula for finding the volume of a cone, which is 1/3 pi r squared height. This will be the radius of the cone, which is here, and this will be the height of the cone. Okay, so if this straight line is rotated 360 degrees about the y-axis, it will form a cone like this. Also a cone, but this time this will be the radius. This will be the height of the cone. Okay, since the solid form is a cone, you can use the formula for finding the volume of a cone to get the volume of revolution, or use integration method. So you will notice that both of them will give you exactly the same answer. Now how about if we have a curve? If this curve is rotated 360 degrees about the x-axis, the solid form will be like this. If it is rotated 360 degrees about the y-axis, the solid form will be like this. In this situation, this is not a straight line, right? So to find the volume of revolution, we need to use the formula that I showed you just now. Okay, now let's try some example. I will talk in this question. I will talk about part A and also part C. Find the volume of revolution when the shape region is rotated through 360 degrees about the x-axis. About the x-axis, we know that we need to use this formula, pi y squared dx. Okay, so these two numbers must come from the x-axis. To find the volume of revolution for the question 15a, we can use two methods. First is using the formula to find the volume of a cone. Second is using integration methods. Let's try both. If this is rotated 360 degrees about the x-axis, it will actually form a cone like this. So the volume generated or volume of revolution is equal to 1 over 3 pi r square height, right? So what is r? R is over here, from here to here. This is 2. X is equal to 2. When x is equal to 2, we know that y is equal to 2 as well. This is 2. So the radius will be 2. 1 over 2 pi r square height. So what is the height? Height is from here until here, which is 2 units as well. Okay, so just press your calculator, you will get 8 over 3 pi. This is a volume generated or volume of revolution. Let's say if you don't want to use this method, you want to use integration method. Let's try. I write the formula first, pi y square dx. So this is a under b. In this situation will be, okay, let me write a under b first. So in this situation, in the exam, you actually don't have to write this formula. You can straight away start from this step. A is 0. B is x. Sorry, not x, 2. Pi y squared. So y is equal to x. So y squared will be equal to x squared dx. Now we can start to do the integration. Pi x 2 plus 1, you will get 3. Whatever you write here, write the same thing for the denominator. Copy the upper limit and lower limit. Substitute the upper limit first. 2 power 3 over 3 minus substitute the lower limit. This will give you 8 over 3 pi. This will give us 0 pi. 0 pi, you don't have to write 0 pi, just write 0. Okay, so the final answer will be 8 over 3 pi cubic unit. You will notice that both methods will give you exactly the same answer. It's totally up to you. You want to use this method or this method. Personally, I feel that this method will be easy. Will be easier. So it's up to you. Some students like to use this one, some students like to use this one. Okay, now let's try 15C, this part. Volume of revolution or volume generated. Volume of revolution. Pi y squared dx, because it is rotated 360 degrees about the x-axis. A will be 1. B will be 2. Pi y squared. So in this situation, I would suggest you to do it this way. Just now, the equation, the function is actually easier. Y is equal to x. This time, y is equal to x squared plus 1. So I would suggest you to do it separately. Y is equal to x squared plus 1. Since that we know we need to use this formula, pi y squared, not y, but y squared dx, we need to find y squared first. Okay, so we need to do some expansion over here. X power 4 plus 2x squared plus 1. If we don't know how to use the formula, you can do it this way. X squared plus 1 times x squared plus 1. Do expansion one by one. At the end, you will still get the same answer like this. Okay, so this is y squared. Pi y squared dx. So if you feel confused, you can always write the formula first. Pi y squared dx. A is equal to 1. B is equal to 2. Copy the pi. Y squared is equal to this one. Don't have to square it anymore. Okay, be careful. This is y squared, not y. So we just copy this whole thing inside. Okay, don't square it because this is already y square. Pi is a constant, you can bring the pi go up. Okay, now only we start to do the integration. X power 4, 4 you have the plus 1, you get 5. Here you write 5. 2x power 2, 2 plus 1 you get 3, you write 3 over here. If you see a constant, you just add an x for it. 2, 1. And then here you need to be more careful. The pi you have to write 2 times. If you don't want to write 2 times, we actually can write it this way, but I will not suggest to write it this way because it looks complicated. Pi. Okay, so this part, bring the 2 go in first. 2 power 5 over 5 plus 2 times 2 power 3 over 3 plus 2. Okay, minus 1 power 5 over 5 plus 2 times 1 power 3 over 3 plus 1. This is for upper limit, this is for lower limit, but if you write this way, it's not correct. We have to add another okay, this braces here. So actually, this look very complicated, right? So I would suggest you to write this for 2 times. It means that this one you bring in here and bring in here. It will be easier. So in this situation, I will do it this way. Let me write over here. Copy the pi. And then bring in the upper limit. 2 power 5 over 5 plus 2 times 2 power 3 over 3 plus 2. Minus, write the pi for one more time. This time it's lower limit. 1 bring in here, here and here. 1 power 5 over 5 plus 2 times 1 power 3 over 3 plus 1. Okay, so to calculate this part, actually you can use your calculator to help you to key in. You can just key in this function first. For example, I just key in this whole thing inside our calculator. X over x power 5. X power 5 over 5 plus another fractions 2x power 3, 2x power 3 over 3, then plus x. Okay, so make sure you key in correctly. Then you press calculate. The calculator will ask you what is the value of x that you are going to use. This is 2, right? So press 2, press equal 2 times. Okay, you will get the answer. 206 over 15. 206 over 15. Remember to write the pi. Then always follow by the minus sign. Okay, then press calculate again. This time we press 1. 2 times of equal 28 over 15. 28 over 15. Same thing, we need to copy the pi. Okay, so the next step, your calculator still remember this. What you need to do, just press 206 over 15 minus answer. Then your calculator know that this answer is pointing to this number. Okay, you will get 178 over 15. If you want to change it to a mixed number, it will be like this: 11 and 13 over 15. 11 and 13 over 15. Remember to write the pi. Okay, so this is the final answer for this question. Let's try two more questions. Find the volume generated when the shape region is revolved 360 degrees above the x-axis. About the x-axis, pi y square dx. Okay, but this time will be a little bit complicated compared with just now one. Now to find the volume of revolution for this shape region, we need to find the volume of a cone first. When the straight line is rotated 360 degrees about the x-axis, you will form a cone like this. Okay. When the curve is rotated 360 degrees, it forms another solid, right? So we need to take the volume of the cone minus the volume of the solid inside. Okay, let me show this one. Hold on. Okay, you can look at this one. Now this is a straight line. When it's rotated 360 degrees, right? It's actually form a cone. The curve, when it's rotated 360 degrees, it forms a shape like this. So what we are going to do is, we need to take the volume of the cone minus the volume of revolution formed by the curve. Can you see it? Okay, now let's try. Find the volume of the cone first. So as I told just now, to find the volume of the cone, you can use integration method, or you can use a formula that finding volume of a cone, which is 1 over 3 pi r square height. Let me erase this one first. Okay, first, I need to know what is the number here so that I know the height of the cone, right? To find the intersection point between this and this, we need to solve them simultaneously. Y is equal to x, first equation. Second equation, y is equal to x squared. Substitute the first equation into the second equation. Y is equal to x, right? I am going to replace this by x. So x squared minus x is equal to 0. Do some factorization. X is equal to 0, or x minus 1 is equal to 0, which is x is equal to 1. We have two intersection points, which is x equal to 0 here, and x is equal to 1. Now I know this is 1. So that means the height of the cone will be 1 unit. Okay, so how about the radius? I need to find the value of y here, so that I know what is the radius of this cone. Y is equal to x, right? When x is equal to 1, y will be equal to 1. So here will be 1 unit as well. Now I know the radius and also the height of the cone. I can find the volume of the cone easily, which is 1 over 3 pi r squared times height. This is volume of the cone. Volume of the cone. So you will get 1 over 3 pi. Now I'm going to find the volume generated by the curve. Use this formula. A is equal to 0. B is equal to 1, from 0 to 1. Pi y squared. Okay, so this is, remember, you have to be more careful. Don't use this since we are talking about volume. generated by the curve, we need to use this one. As I told just now, I will suggest you to do separately. Y is equal to x squared. So y squared is equal to x squared. You square it again, which will give you, let me write this way, x power 4. Okay, so pi y squared, which is x power 4, dx. Now we can start to do the integration. So same thing, this is pi is a constant. If you want, you can pull it out. If you don't want, just keep inside, it's okay. 4 plus 1, you get 5. Here we write 5. Upper limit, lower limit. Bring in the upper limit first. Pi times 1 power 5 over 5 minus pi times 0 power 5 over 5. So here will give you 1 over 5 pi. This will give you 0, right? Okay, this is a volume generated by the curve, and this is a volume generated by the straight line, which is a cone. So we want to find the volume generated by the shaded region. It will be this 1 over 3 pi minus 1 over 5 pi. So this one you can just press your calculator, 1 over 3 minus 1 over 5. This is the answer for this question. Okay, so let's say if you don't want to use this method, we can try another method. Let's try, so see whether we get exactly the same answer or different answer. First, I will find the volume of the cone, but this time I will be using this formula. 0 under 1 pi y squared, so this is x squared, dx, minus, this is the volume of a cone, this is the volume of formed by the curve, pi y squared x power 4 dx. Since you know the limit is actually the same, lower limit and upper limit the same, you can combine them together. Like this. The pi, you can just bring it out. Okay, now we can start to do the integration. X power 2 plus 1 you get 3, here you write 3 also. 4 plus 1 you get 5, here you write 5 also. Okay, 1, 0. Remember this, the pi you have to write 2 times. Bring in the upper limit first. 1 power 3 over 3 minus 1 power 5 over 5. This time, bring in the lower limit. 0 power 3, 0 power 5. You will notice that this will actually give you 0, right? So just press your calculator for this part. You will still get the same answer. 2 over 15 pi. Okay, so be careful. 1 power 3 is actually 1. 1 power 5, 1 as well. Okay? Both give you the same answer. Okay, let's try one more question. Let's try part B. So we want to find the volume generated when this shaded region revolve 360 degrees about the x-axis using the same formula, x-axis, dx. If this is dx, these two numbers come from x-axis. So I'm going to break it become two parts. First, I find the volume generated by this curve when it's rotated 360 degrees about the x-axis. Second, I find the volume generated by this straight line, this part, which is actually a cone. So same thing, you can use the formula of the formula. Sorry, you can use the formula for finding the volume of a cone, or you can use integration method. Okay, now let's find the volume for this part first. To find the volume for this part, we know that we need this value, lower limit and upper limit. The problem is we don't have this one. We don't have this. So we need to find the intersection point first. Same thing, we need to solve them simultaneously. Y is equal to negative x plus 6, first equation. And the second equation is y is equal to x squared, second equation. Substitute the first equation into the second equation. Minus x plus 6 is equal to x squared. So this is a quadratic equation. We arrange the quadratic equation nicely, right in the general form. Then only we start to do the factorization. X squared plus x minus 6 is equal to 0. Do some factorization over here. X, this is 3, 2. You can use your calculator to help you. X minus 2 is equal to 0, or x plus 3 is equal to 0. So x is equal to negative 3, x is equal to 2. Negative 3 is somewhere around here. That is another intersection point, but we are not looking for that point. What we want is 2. So now we know that this is 2. Okay, so we can start to find the volume of revolution for this part. 0 until 2 pi y squared. Okay, so y is equal to x squared. Y squared will be equal to x power 4 pi y squared dx. 4 plus 1, you get 5. This is 5. And this is 2, 0. Okay, until here, I think it should be no problem, right? 2 power 5 over 5 minus, bring in the lower limit, which is 0. Okay, this will give you 0. So 2 power 5 is equal to 32. 32 over 5 pi. This is the volume of revolution for this part. So now I'm going to find the volume of revolution for the straight line, which is actually a cone. This time I will use the cone formula, 1 over 3 pi r squared height. So height, I don't know that's one. If I want to know the height, right? Or if I want to use the integration method to find the volume revolution, I need the lower limit and upper limit. I need to find this point. This point. On x-axis, y is equal to 0, right? I want to find the x-intercept. Y is equal to negative x plus 6. On x-axis, y is equal to 0, negative x plus 6. So from here, we know that x is equal to 6. Now we know this is actually equal to 6. So I have the lower limit and upper limit if I want to use the integration method. But this, now I want to use a formula for the volume of a cone. I need to find the radius, which I need to know what is the radius for this cone. Y is equal to x squared. When x is equal to 2, y is equal to 2 squared, which is 4. Now I know that this is 4. So the radius of the cone is 4 units. The height of the cone is 4 units as well. Okay, let me continue here. 1 over 3 pi r square, radius 4 units. Height, so 6 minus 2, you will get 4 units. Okay, so this is 64 over 3 pi. Now, the final answer, we just take this two, add up together. You will get 416 over 15 pi. If you want to change to a mixed number, it will be 27 and 11 over 15 pi. Okay, so if you don't want to use this method, let me try another method, see whether I get exactly the same answer here. If I want to use a formula to find the volume of the cone, I just need the lower limit and upper limit. I don't need the height. So which is 26 pi y square. Don't use this one. This is a straight line, so we have to take this one. So as I told you just now, I will suggest you to do outside here. Y is equal to minus x plus 6. Or you can change it to 6 minus x. So y square is equal to 6 minus x square. In this situation, the x inside the parentheses is power 1. You can expand it like what I showed just now. If you don't want, you can just use a formula that I told you before. Okay, here I'm going to use a formula. Dx. Okay, start to integrate it. So how about I bring the pi out, go out first. 6 minus x square. Okay, now start the integration process. 6 minus x, 2 plus 1 power 3, whatever I write here, write the same thing for the denominator. And don't forget, you cannot stop here first. You cannot stop here yet. You have to differentiate inside the function inside here, which will give you actually -1. Okay, so let's try using this method, see whether we can get this answer or not. Bring in the upper limit first. 6 minus 6 power 3, and this is 3 minus 1. 3 times -1 will give you -3. Minus pi again. This time lower limit. 6 minus 2 power 3. This is -3. Okay. So 6 minus 6 will actually give you 0. So power 3 you will get 0 as well. 0 divided by -3 you get 0. So here will be 0. Minus, copy the pi first. 6 minus 4, 6 minus 2 will give you 4. 4 power 3 is equal to 64. This is -3. Okay, so negative will give you positive. Eventually you will get 64 over 3 pi. Same answer. Both methods will give you the same answer. So same thing, if you are using this method, take this one plus the volume of revolution for this part, then it will be the final answer. Okay, so for this video I stop here first. In the next video only I will talk about when a curve or straight line rotated 360 degrees about the y-axis. Okay, see you next time. Thanks for watching. Bye bye.